Hi AMs, this is Kevin AD0IM with a long overdue video that shows essentially the day-by-day build of my QRP Labs 20-meter QRP CW rig. There's already been a couple of videos on this, including showing it on the bench getting tested, so I encourage you to go look at those too if you haven't seen them yet. This is a video that was supposed to be in between those two, but I just got kind of lazy and just wasn't doing everything in the right order. But here's what the board looks like when you first put it on your bench and after you've added this nifty toroid right here in the middle. This is a transformer, and I will tell you again and again and again that I'm not an expert. I built this thing, I assembled this thing, but how all the parts interact, I cannot tell you. I have been studying up on transformers of this type a little bit, and all I've been able to figure out so far is that, at least in this particular case, and I'm sorry I don't know how to zoom in on this, the power comes into this primary winding here. So there's 4 windings on this toroid, 3 that are 3 wraps through the toroid each, and then one that's I forget the number. Let's just say 20 at this point. I think it's higher than that, but there's a lot of windings on that, and so there's 8 solder joints that you have to line up and solder onto the board in order for this thing to do its job. And that's really all I can tell you, except that it's really, really small. And in one of the other videos, you might see something that gives this some scale. But this is by far the most intimidating part of the job, is getting this transformer assembled and soldered onto the board. I'm not going to belabor this point. It's in the manual. There's a whole bunch of help on how to get this part done. As I stated in an earlier video, this was my second attempt at this project. So I think the first time I did it, it took like half a day to get the transformer on the board. This time it took about a half an hour. Pardon me. So 30 minutes was not that bad. And it was really the only thing I did that day. So I put this on the board, and then I put the project away and moved on to the next page of the instructions. That's the transformer. Now the next day, I put all my sockets on for the ICs. There's, a fair number of ICs that make this rig run. And, the instructions in the manual, suggest not using sockets and just solder the ICs directly onto the board. But the soldering is so small on this board, and I'm still fairly new to all this, and I didn't want to damage an IC with a wayward soldering iron while I was putting on other components around it, because the ICs go on very early in the process, and I just didn't want to deal with that. So I went ahead and bought some sockets, and I went ahead and put the sockets on. And I think this 14 pin up here I had to remove and put back on again because I put it in the wrong direction initially. But it got on there. These are all on here very nicely. And then the next day I came back and I started putting some of the capacitors on here. I will tell you, as we get into some of these pictures, that I was incredibly patient with the soldering on this. I only did about 15, a maximum of 15 components a day. Most of the components had two leads on them, so that was about 30 solder joints that I did each day. And then what I would do is flip the board over, take a very tiny little screwdriver, scrape off excess flux, look under a magnifying glass for any errant solder bridges that may have occurred, took care of those, and then I gave the whole back of the board a little alcohol bath. And you'll see the fruits of that labor here in a later picture. But it really helped me maintain a steady cadence during the project. And, I was able to get it done in 12 or 13 sessions of about an hour per session. So it went pretty fast, at least on total number of hours spent. But like I said, I was very patient. I didn't stretch myself, and I think it really came out well. And you'll see some of that as we move forward. So it took a couple days to get all the capacitors, a couple of sessions to get all the capacitors on. And then you go into resistors and some crystal oscillators and some diodes. I neglected to say that the board did have two surface mount chips on it, but those were already in place when they shipped the board, so you don't have to worry about putting those on the board yourself. So that's one of the good things about this kit, is while some of the soldering is small and a little tedious, at least you're not messing with with chips this size. So that was good. So, spend a few days or a few sessions. I need to quit calling them days and call them sessions. Just getting all the little stuff put on the board. And after you get, the vast majority of the resistors and components and even some of the larger capacitors on the board, then it's time to start dealing with, some of the variable resistors. Now there are, you can see 3 of them in this picture, and I think that's all there were. I don't recall exactly, and I haven't seen the inside of the radio for a little while. But one of these is unique. Its model number is unique, and then the others are all identical. So you have to take care on some of these components to make sure you identify the ones that are unique and get them in the right place. And then you can move on and put all of the others in. And the only thing you have to worry about is orientation, making sure that that this end of the component is facing in the right direction. All right. So all of your polarized components, you have to take care to do that, obviously. In this picture up here, you can visibly see a fairly large diode. And this is actually the circuit protection diode. That's what I'm going to call it, because I forget what it's called in the documentation. But that is the diode that protects your kit from cross-polarization of your power supply. All right. So if you cross-polarize your power supplies, cross the streams, as we might say, Ghostbusters fans, this diode will prevent that current from coming on board and wrecking your project. Now there is some loss. There is some power output loss with this diode, and the instructions in the manual do advise you of that. And they do give you the option to not install the diode, but instead just put a little lead or a jumper between these two solder joints, between these two through holes here, and you can avoid using the diode and increase your power output a little bit if that's that important to you. But I put it in because, I'm kind of dangerous sometimes. So moving on to the next one here, you'll notice there's a big washer and a nut and a bolt here, and four MOSFETs. And these MOSFETs, I just saw a video the other day that explained what they do, and I've already forgotten it. And as I will continue to remind you, I'm not an expert, but these were tricky to install, and I wished I'd have taken a picture of it before I put the nut and the bolt and the washer on there. But the nut and the bolt and the washer act as a heat sink for these guys, because they do generate some heat. And this is kind of just a heat sink for those 4 components. So one of these days I'll make a video that fully explains what all of these things do, and I'll have the documentation in front of me as I do it. But right now I just want to give you a flavor for the size of the project and the scope of it. There's a potentiometer over here. This one's important when you go to align the transceiver after you finish building it, and you're adjusting the receiver section and making sure that you get the sensitivity and the gain set correctly. after you build the kit and before you fully enclose it in the case. So, so those are some of the things that are on at this point. A little later on, you add all of your connectors. There's a nice 5-volt power regulator here. This guy gets pretty hot too. And in the final assembly, this is attached to the aluminum case, or the metal case, with a nut and a bolt, and that kind of turns the case into one big heat sink for this voltage regulator. So there's a couple of clever little designs here that are incorporated into this kit. But there's connectors on this kit for obviously your 12 volts in, 13.8 in the case of this. This is your audio output. This is your Morse code output. And then these other two, one of them, I can't remember. Oh, one of them is a connection to the power amplifier. So if you go ahead and build a power amplifier for this rig, I believe this port here is a connection to that. I could be wrong. It might be this one. But in any case, there's a power out to the amplifier built onto the board here. And this is obviously your BNC antenna port. We talked about the transformer earlier. Let's talk a little bit about the bandpass filter, and that's this collection of toroids here. I think it's called a low-pass filter, to be technically correct. And the interesting thing about these, along with this red one here, is that in the instructions, they tell you to wind these toroids so that all the windings are fairly close together. But when you go to check your power output, if you put them too close together, you'll find you're putting out a watt or less than a watt. So what they tell you to do in the troubleshooting is to come back in and spread these windings out, and that will improve your power output. So just know if you've never built one of these before, that's a step you're going to have to take in order to get the power output to a level of that satisfies you. I was not too anal retentive on that, and you see that in video number 2 on this project, where we actually do put this on the bench and test the power output. So at the end of the day, the power output for this came out just fine for me, somewhere between 4 and 6 watts. Tolerance of the power meter taken into account there. And I believe this next picture shows you the back of the board after I've soldered everything on. This is a very clean soldering job, if I do say so myself, especially for some. If you'd seen the first board that I did for this, you would say, wow, that guy's a clown. He doesn't know what he's doing. And that's true. I really don't. But using the steps that I outlined earlier, making sure to I used a lot less solder on this one than I did on the first attempt. There was so much solder on the first board, it was insane. But I did a much better job on this. I regulated my solder a lot better, and I really don't have any grossly oversized solder joints here. So that came out cleaner. Like I said, cleaning flux off and getting rid of solder bridges the day that at the end of each session. And then, like I said, with a little toothbrush and some rubbing alcohol, scrubbing the board down after I knocked everything loose and getting everything nice and clean and shiny. It really paid off. It's a very clean soldering job. I'm very proud of it. And these are all techniques I'm going to use going forward on future projects. So that's it. We're back to the first slide. So that's kind of how I went about soldering the main board. I don't have any pictures of the display board where all the controls are. That was a much smaller project, and but I will say, by the time you get done putting this board together, you're not really you're kind of done documenting. You want to get the project done, and the display board is a much easier project. Now, assembling the display, the front end display for this rig, is a bit of a challenge. But follow the instructions to the letter, and read everything 2 or 3 times before you do something, because you'll be amazed what you see the second or third time that you do something. So I'm just coming back here to look one more time to see if I missed anything, but that's essentially it. There are some things I haven't covered here, but this is what the main board essentially looks like once you get it done. The last step is to install some connectors over here to which the display board connects. So the display board will be at this end of the kit, and then all of your inputs and outputs are back here. And then obviously really the last step before you put it all together is to insert your ICs into your sockets, which is a tricky bit. I will point that out. The pins on those ICs, are flared outward quite a bit. So, you have to exercise some care getting those angles, those flares adjusted to where the chips will glide into your sockets or the circuit board. If you choose to solder your ICs directly onto the board, you're going to be, kind of working on those pins or those leads to get them to line up correctly before you solder them on. So, and as you do that, obviously, you need to make sure that your dimples are lined up so that the IC is facing in the right direction. So, so that all the circuitry is flowing in the right direction. There's another thing that I've left off here, and that's the installation of the AGC module. I didn't really do that until I had the rest of the kit all assembled and I'd fully tested it and even made some contacts on it. And then kind of as an afterthought, I put the AGC module in. That was a little tricky, and I don't think there's any really good videos out there, so I promise that if I build another version of this kit, say the 40-meter one, that I will document that part of the assembly better. But we'll see. The next project I have in line for this is the power amplifier kit. So I'll be doing that next. So anyway, I'll let you guys go at this point, and I hope you enjoyed this. And if you have any questions or comments about this, please put them below. And look forward to seeing you again soon. This is Kevin, AD0IM, saying 73.